Hello everyone, I am Harriet Linda from SRM Institute of Science and Technology. So in this video, I am just going to explain an interesting topic called backtracking with Enquiries problem. So first of all, I want to tell what is backtracking. So backtracking is nothing but it is a problem solving technique. So it finds out a solution by trying the different options. So normally a backtracking, it is explained by means of a state space tree. State space tree is nothing but it is a rooted tree. So in which the first node, that is nothing but it is called as the initial node. It tells what is the initial solution, and each and every node that represents a state, that is nothing but it is normally called as a partial solution. So the edge that tells about a decision or a choice. So what choice we can able to have. So normally, so from if there is a solution that is a partial solution, it comes from the initial solution to the next state. So normally what technique that follows in the backtracking is normally called as depth first search. We are using DVS. So leaf node, so normally it is having two solutions. One is a valid solution. So if the leaf node it gives a valid solution, means normally we are just calling that one as a solution. So that is normally given here. So if it is an invalid solution, means that is normally called as a dead end. So if dead end is obtained, that is an invalid solution, means we are going to prune the branch and backtrack to the previous solution. So from the previous solution, we are just going to have another one partial solution. So that is the normal concept what we are just going to do in the case of backtracking. So that is given as, so if an invalid state, that is normally a dead end occurs. So we are just going to undoing them and we are just going to the previous solution. So that is normally called as a backtracking. So next main concept, how the backtracking works, I am just going to tell here. We are just going to choose the initial solution. Then we are just going to explore all the possible extensions of the current solution. So what technique I am just going to use here is DFS, depth first search. So if the extension leads to solution, that normally returns a solution. If does not lead to a solution, means what we have to do means we have to backtrack to the previous solution and we have to try another one, that is the option. So these steps are repeated again and again until we are just going to reach a possible solution. That is the normal case of a backtracking. So some problems, it is not having a single solution. It can have multiple solutions. For reaching this multiple solution, we are just going to do with different options. So some of the applications of backtracking are, so one is the Enquiries problem. Next one is sum of subset problem. Another one that is the graph coloring problem. Another one that is the Hamiltonian circuit problem. So in this video, I am just going to explain the concept of Enquiries problem. What is Enquiries problem? So normally Enquiries problem, here I am just going to use a problem solving technique that is called as a backtracking. So backtracking technique I am just going to use in this one. So Enquiries is, normally we are just going to use a n cross n chessboard. That is the main concept in this one. If you are just going to use an n cross n chessboard, I'm just going to place how many queens means n queens. So n queens, there should not be two attacks. So that is no two queens on the same row or on the same column or on the diagonal. So see here, if it is a 4 queens problem, the n is equal to 4. So here I am just showing a figure which demonstrates the 4 cross 4 chessboard. So here how many rows here? 4 rows are there, 4 columns are there. I am just want to place the first queen on the first row, second queen on the second row, third queen on the third row and the fourth queen on the fourth row. Similarly, If n is equal to 8, that particular problem is normally called as 8 queens problem. So in that, how many queens we have to place is, we have to place 8 queens at a time. So this is the concept of n queens problem. How to solve this n queens problem, I am just going to explain in this one. So very concept is, here we are just going to use a constraint. The constraint is, that is, no two queens, they should not be on the same row or the column or the diagonal. So two concept we are just having. We can place two states we can have. One is the safe state, another one is the unsafe state. Safe state is, we are just going to place a queue and going to move to the next row. One queue is placed on the particular row, and we are just going to skip on to the next row. That is, not safe is, if we are just going to place a queue on a particular row and it is affected by another one queueness, it is normally called as a unsafe state. If there is unsafe status, we are just going to remove that queuing and going to the previous solution and trying another one option. So normally that is called as safe state, and another one is the unsafe state. So normally if n is equal to 2, that particular problem, it is called as Twicken's problem. For if n is equal to 2, the concept is there is no solution. Because if I am just placing a queue on the first row, first column means I am not able to place the queue on the next column. Here also, row wise also it is not possible. Diagonal also not possible. So there is no solution if n is equal to 2. Basic concept here, I am just going to use a 4 queens problem. So 4 queens problem means how many rows are there? 4 rows are there and 4 columns are there. 4 queens means that is nothing but it is telling about 4 cross 4 board. So what is in this 4 queens problem? So first I am just going to place the first queue on the first row, first column. So main concept here is, this is the first choice in the state space tree. This is the root. I am just going to place the first queue on the first row, first column. So basic concept is, now I am not able to place any queue on the first row. I am not able to place any queue on the first column, and on the diagonal also it is not possible. So this is the basic concept. So I am just going to the next state. So next, so this is not possible because there is a diagonal attack. So I am just going to place the queue on the third column on the second row. Second queue is placed on the third column of the second row. So this choice is given here from C1. We are just going to the C3 because I am just going to place the queue on the third column. So now I am not able to place any queue on the third column or on the second row. The diagonal also. So this is the concept. You are not able to place the queue. So next choice. So if we are just going to have here, I am not able to place any queue on this one. So first column also it is not able to place any queue. So I am not able to place any queue on the third row. So normally this is called as a dead end. So if dead end is obtained, I am just going to the previous state. So that is the concept. I am just going to change the position. I am just going to, this is called as an invalid choice. I am just going to change the position. So position, what is the next position means, instead of placing the queue on the third column of the second row, I am just going to place the queue on the fourth column of the second row. So the choice is given as C4. So if I am just going to place here, I am not able to place the queue here. I am not able to place the queue here on the third row. Here on the first column also it is not possible. But we are just able to place the queue here. So this is another one case. So I am just going to place the queue on the second column of the third row. So this is given here. So now I am just in a situation to check whether I am able to place the queue here In the fourth row, it is not possible because we are having an attack here. Here also it is not possible. Here also it is not possible. Here also it is not possible. So this is also called as a dead end. So we are just taking here as a dead end. So there is no possible solution. So what is the concept is I'm just going to backtrack now. Backtracking is going to the previous solution. So previous solution means I'm just going to this previous solution. I'm not able to place any Q on the third row. I'm not able to place any Q on the second row. So what the choice is, I'm just going to change the first Q. So now instead of placing the Q on the first row, first column, I'm just going to place the Q on the first row, second column. I'm just going to take some choices here. I'm not able to place the second Q on the second row, first column. Here also it is not possible. In this also it is not possible, but I am just able to place the Q here. So what is the choice here? So from this one, I'm just going to the next one. C4 is the choice. So if the C4 is the choice, so this is the basic concept here. I'm just going to place the Q on the second row, fourth column. Now I'm just going to check the third Q. So whether it can be placed on this content, so it is possible. I'm just able to place the third Q on the third row, first column. I'm just placing the Q here. So that is normally given as C1. So now I'm just going to check here whether it is able to place the Q here. It is not possible. Able to place the Q here. It is not possible. So whether to place the Q here, that is in the fourth column, it is not possible. But we can place the Q in this one. There is no attack on the third column. So this is one of the solution. Now I am just getting a solution. So this is called as a valid solution. So the basic solution here we are just giving here is 2, 4, 1, 3. What is the meaning here? The first Q is placed on the second column. Second Q is placed on the fourth column of the second row. Third Q is placed on the first column of the third row. And third Q is placed on the third column of the fourth row. So this is one of the solution. One solution is found here. Now, in order to find out another one solution, I'm just going to place the Q on the third column of the first row. I'm just placing the Q here. Going to the next solution, I'm now able to place the Q on the first column of the second row. Next, I'm just able to place the Q on the fourth column of the third row. So is any other choice? Here I'm just having a choice. So for an Enquiries problem, we are having two solutions. So one solution is given here. So this is one of the solution. Another solution is this solution. So that is the concept of a state space tree. So we are not able to restrict with a single solution. So we are just going to find out multiple solution in the case of this concept. So that is normally called as a four queens problem, which just implemented by this one. So this is a simple state space tree of a four queens problem. So initially this is the initial state. What I explained in the previous slides, I'm just going to explain here as a single diagram. So this one is the initial state. The first Q is placed on the first row, first column. So here in the second row, I'm not able to place the first Q on the first row, first column. I'm not able to place the Q on the second column, but I'm just able to place the Q on the third column. If I place the Q on the third column, again we are not having any solution. So this is normally called as a dead end. I'm just getting a dead end. If a dead end is reached, what I'm just going to do here is backtrack to the previous solution, going to change the Q, then the second row. I'm just going to place the Q in the second row as the fourth column. Again, I'm just going to take some solution. I'm not able to place the third Q on the third row, first column. Not able to place the Q on the third row, third column. Not able to place the Q on the third row, fourth column. But I am just able to place the Q on the second column of the third row. Even I place the second Q on that one, here I am just getting a dead end. So this is also a dead end. So I am just going to backtrack. So this cannot be further explored. I'm just going to the initial state, changing the first queue. I'm just going to place the queue on the uh, first row, second column. So I'm not able to place the second queue on the first column of the second row, or the second column of the second row, or the third column of the second row. But I'm just able to place the queue on the fourth column of the second row. We are just expanding and I'm just getting a solution. So this is normally a state space tree of a four queens problem. So this is showing only a partial concept of this one. Only one solution is given here. So this is normally an 8 queens problem. So what is 8 queens problem means, what we have to use here is 8 cross 8 chessboard, and how many queens I want to place here is 8 queens. So that is the concept of an 8 queens problem. I want to place 8 queens in an 8 cross 8 chessboard. So this is one of the solution of an 8 queens problem. Likewise, we can able to have 92 distinct solutions for the 8 queens problem. Not a single solution. We can have 92 distinct solution. Among this one, we can able to have 12 unique solutions. So that is nothing but it is an 8 queens problem. So one more concept I want to explain here is how we are just going to implement this n queens problem is. So simply I want to place the Q. That is the main concept. So Q should be placed here. I'm just going to give here is K queen should be placed on the kth row in the ith column. So in the ith column, I want to check whether there is any attack or not. That is the main concept what you want to check in the n queens problem. So attack means there should not be any attack. That is some constraints we are having. One is the row constraint, column constraint, and another one is the diagonal constraint. Three constraints we are just able to check here. One is the row, one is the column, another one is the diagonal constraint. So what we are just going to check here is, we are just going to check x of j that is equal to I. Another one condition is abs of x of j minus I that is equal to abs of j minus k. So this is used to check whether there is any attack on this one. So if any attack there means we are not able to place that q there. Okay, so if the particular, so now I told that normally we are just having two states. One is the safe state, another one is the unsafe state. So if there is a safe state, I'm just going to place the Q in this one. What is in this one is, we are just going to maintain a particular list that tells the position of the Q. If not, I'm just going to the next row. So that is the normal thing what is given in the case of the n queens problem. So see here in the n queens problem, so in the n queen, that is in that particular pseudocode also, we are just having a loop from I equal to 1 to n. So here in each and every time, we are just going to check whether we are able to place the q on that particular chessboard. So that is automatically going to check here. Again here j is equal to 1 to k minus 1. So what is k minus 1? So that depends upon the n rows as well as n columns. So what is the time complexity here is O of n power n. So that is the normal time complexity what we are just going to have in the n queens problem. So thank you. So in the next lecture, we are just going to explain another one application on the backtracking problem. So thank you very much.